Good evening and welcome to this video on the first derivative of x squared. Given y is equal to x squared, dy over dx, differentiating y with respect to x is 2 times x to the power of 2 minus 1, which is equal to 2x. This follows the simple method of differentiating the powers of x. Given y is equal to x to the power of n, dy over dx, differentiating y with respect to x is n times x to the power of n minus 1. And what is the background? How do we prove this? Here comes the first principles method, FPM. Alright, FPM says f dash of x is equal to limit h tending to 0, f of x plus h minus f of x divided by h. Given y is equal to x squared, I just replace y as f of x because we know y is a function of x. So therefore f of x plus h is going to be x plus h the whole square. We just replace x to be x plus h and then expand this using a plus b whole square, which is x squared plus 2 times x times h plus h squared. So therefore f dash of x, which is equal to limit h tending to 0, I replaced f of x plus h with this expansion, which is x squared plus 2 times x times h plus h squared minus f of x could be replaced as x squared. Alright, I can just simplify this. Positive x squared and negative x squared becomes 0, and we have f dash of x which is equal to limit h tending to 0, 2 times x times h plus h squared divided by h. We cannot simply apply the limit as the denominator becomes 0. If you have a fraction whose denominator is equal to 0, the value of the fraction becomes larger and larger, and there is no fixed number and which cannot be defined. Basically, that is the reason why we use some algebraic manipulation here. So I just factor the numerator and bring h outside the parentheses, and we have h times 2x plus h divided by h. Now we have a complete product on the numerator. Just cross this h here and here at the denominator. Alright. So therefore we have limit h tending to 0, 2x plus h. You could take this 2x to be one function and h to be another function. Since the limit can go to 2x and the limit can go to h, alright, since 2x has no since 2x has no h involved, the 2x will remain the same when you apply the limit. And limit h tending to 0, this h becomes 0. Technically we just replace h to be 0. Alright, therefore f dash of x is equal to 2x. I hope you understood, and this is the background and this is the proof. So FPM, let us make it more popular, and because this first principles method helps us to prove more, the first derivative of more standard functions. I hope you enjoyed this video. If you're watching, please subscribe my channel. Do like and share as well. Thank you for watching, and I will see you in my next video.